Hey, I am being broadcasted. Hey, so let's take a look at this. Let me go ahead. Delicious. I forgot here. Where the heck are we streaming to? Is this YouTube? Okay, good. I was about to say. We do need some. Do they even have that thing here? Anyways, what are we looking at here? I got 3 computers, 2 servers, and a 12th generation. Yes, it's a 12th generation 20 core i7. It has my 4080. I can't put that 4080. This is not professional. Hold on a second. I shouldn't have any food here. Oh my god. Not prepared for this. And I'm it's the work. Yes, baby, yes. Don't dog this. Okay, here we go. Alright, so because I've been working on training small little models with all kinds of data sets here, I figured, hey, we applied everything we learned, and I want to manage all my computers. I want one interface because I don't have a screen that's big enough to see everything. I want AI to be running in the background, right? When it comes to the logs, which I haven't implemented yet, but it comes to the logs, any connection coming in, even the data that's inside of it, I want everything to be. I don't want to normalize it. I don't want to average it. I want to find anomalies. I want to find patterns, and then anything that is catchy, I get warnings. Either text messages, Telegram. Right now, I'm big on Telegram. The Telegram, I'm really getting used to this thing. All right, so 2 servers on the bottom. You know, my .39 doesn't do much work. Most of the machines are 99%, 95, 99% idle for the most part. So right here, there's I think some drives that are not mounted, but it's about 45 terabytes total. It's not much. 786 DDR4 for the most part. The gaming has 32, so that's probably the fastest. 372 cores total. So I have 372 cores to play around with here. Now, so the 2 bottom ones, I am going to show you really quickly. Let me add a new screen capture. Sorry. We're brave. Oh! There's my YouTube. Alright, let's just close all this stuff. Okay, what do we have here? Please don't hack my website. Anyways, I just wanted to show you something real quick. So here we have it's a domain. It's a custom. What is the freaking term I'm looking for? A domain specific language. So I had obviously Vibe. I had AI help me make a domain-specific language that combines Lua with a little bit of assembly in order to do like really fast matrix multiplications. I'm sort of reinventing the wheel a little bit here, but let me just actually bring this. I'll put it over here, just real quick, because I wanted to show you that when I do a distributed test, because I already have those 2 machines as part of the node, watch them do spike together. That's how I know it works. Come on. I think somebody is, if you do too many like website, I gotta work on that. Fail to ban is a little finicky right now. It's just like, okay, let's start. Okay, there you go. You see that line right here? I'm gonna do it again. I'm gonna set the load. So it did that computation in 10.68 milliseconds. So that's how I know they're working together. Okay, do like that. Bop, 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 bop. Yep. And then, no matter what, so this is the cool thing. So my domain specific engine that I put together, what it does is it's a virtual machine, right? And we can just go into the code. I'm still trying to figure out how it works. But what I did basically was we had a basic function that did a computation, and then what we did was we had the output, right, AVX, and then what we did was measure this, and then change parameter as you go, a discovery, and then as you discover, if you break the high score, recompile the parameters back into the binary. That way we have the binary that has the most optimized parameter, right? And so that's part of the kernel. So, but then also put restriction. Actually, the first model, which I don't think, it's kind of cool because probably you can share with the world, but you don't know anybody who can appreciate this, honestly. But my first one actually was a restrictive kernel that it was basically, it was almost like a pressurized memory kind of thing. I went on a rabbit hole. So how does it work best under the most pressure, more restrictive conditions? So how can something work on, let's say, you have 100 kilobytes per second, 100 kilobytes of memory, and you can only do so much compute in this amount of time, or else you can't do it. So I actually took some part of that into this kernel, where, well, let's just show the proof here. Let's actually, yes, my best friend. So all you got to do here, let me go to my codecs real quick. That's part of, okay, I might have to go to my Visual Studio. I don't have enough screens. Alright, so let's go to the source code. It's gonna be my engine. Where's my engine? And that's a problem with AI. You have to be careful because that thing will start replacing things. Okay. It's only around 3,300 lines of code. Okay. But what I want is, bear with me, it's my readme. There you go. Alright, cool. So I tell my AI, hey, here is my readme for my domains. Write me a complex matrix tensor using tensor. Alright, it should have it in the context. Hold on a second. Also distributed across nodes. Alright, my friends, am I still live? Yes, I am. Bobby, my best friend. Check this out. So let me see. So okay, good. We started the jobs. So ChatGPT doesn't know anything about this, but I already had some context instructions into a project, so that's probably also what it's pulling from there. So you can build a language, right? So the high level stuff, you can make it whatever you want, but the low level stuff is use AVX. If you have a GPU, which I haven't implemented, I have like a dummy template where if you have a GPU, we can also do this. But here we give 2 jobs, so we want to declare that first. Yes. Okay. Okay, you're hitting layers, and then it's also giving it to it. Okay. Okay. Yeah. So that one just runs it. Okay. Let's copy it. So now we got it loaded, right? Watch this. Run. We got a problem here. So now we copy this right here because we're going to tell it that you messed up on line 37. You're not bueno on my programming. Okay. There are some limitations. One thing I've noticed with ChatGPT writing programs for my domain specific language, um, domain specific, yo, my ADHD is kicking in. Yo, yes, it's specific. Why am I doubting myself? All right, it gets triggery. It gets triggery sometimes. There we go. Boom. Let me do it again. Boom. 46 milliseconds. Okay. Now, are we distributing? Yeah. Let's do it 3 times. There you go. That's it. So I know it's working. So then I copy this right here, right? And I give it to the AI. And so kind of see like, hey, how did I do? Check this out, baby. Check this out, baby. I'm excited. No, seriously. AI is here to help. You can't do everything. You gotta do some of the. You gotta do some of the work here. Look, this is actually mango passion fruit. This thing says a studio mode. What do you do with studio mode? I don't do any other comments. I'm old school, and I like answer now, please, because you take forever. Okay, what can you tell me? It confirms the remote just sent to the request. I already saw it. Okay, 29 steps. Okay. It's only a 4x4. You just give. Oh my god. Give me a super big matrix, please. Give me difficulty. By the way, I talk to this thing sometimes. Okay, okay. It wants to do 1024 by 1024. What do you think is going to happen to my thing? It's going to go crazy. Alright, this is very disorganized. Why are you doing this, Jose? Okay, let's fix this here a little bit. No bueno, muchacho. Gotta work on this stuff. No, seriously, let's go back to it. Apparently, it's going to push it to the limit. Well, it should be sufficiently efficiency to prevent you from breaking it. And you broke your own code. So this is kind of AI not understanding. Keep in mind, it's almost, it should be like 37, 30. No. There's definitely over 4,000 lines of code. So it can understand the language, but I don't understand some of the mechanics. I can feed it the engine.c because it's all written in C code. The one I have on my GitHub, it's with Swift because I have it on my M4. I don't think anybody's viewing, but you never know. Can have a couple birds coming in there. Watching myself. Alright. Let's see. I have some memory caps, that's why. Let's see if we can actually make this one work. Nope. Doesn't work. Let's see. Yeah, ChatGPT is not doing good. This is why I am not worried about AI yet. Because, I mean, maybe they have some models that are pretty crazy and they can actually. But if I give it my engine program, my source code completely, which already has like 99% of it, I only make a few changes here and there. I can't go through all the source code. I only went through to make sure that I don't have any credentials or anything, which I'm expecting to get compromised. If I keep going at this pace, I am going to get compromised. Boom! There's a spike right there. And that's only two, well, that's most of the cores right there. Let me see. And that doesn't even put it that, we're dealing with like child play. Let's see. Tell me something good, AI. So I spent some time like copy pasting the benchmarks, and that's how I started tweaking, you know. And then anybody goes on the website, I can also see like, hey, someone's abusing it, ban that IP. They tend to do this to me a lot. Whenever I see this interruptions, I already know ChatGPT is getting too smart. Look at that, they do this stuff to me. They start throwing me. It only compiles 62 instructions. Oh, okay. It went. Yeah, because I have it. You know what? I'm gonna change that max limit. Bless me, Jesus. Thank you. Yeah, because it reached the limit there. Look, it nailed it. It said that one of my computers 128 cores and the other one is at 48. I never told you that, buddy. Unless it pulled that from the context. I never told it that. So he knew that already. Yeah, no 2 is 2 times faster, I know. Oh, apparently slow. Okay. So we had a memory of 1.57 megabyte. Yeah, Fusion. So I have this thing called Fusion. And so what happens is, let's see, you write a very, and maybe it's because of the array limit that I have. If I expand on the limit and we can explore more of the hardware, I'm kind of scared because I only have a 1000 watt. And so that my journey to go to YouTube and try to explore is because I need some more money to invest in equipment so I can explore infinite spaces. But Fusion, what it does is, let's think of writing a function. You know what? Next thing I'm going to get is a whiteboard. You think of a function, and you create some variables, which, let's say you are dynamically allocating some memory for some sort of variable. And then you're performing some computation, right? So the engine, the program, should look at that and run it, have a base, right? And then over time, as it learns, the neural network learns, it should explore and say, well, I seen this and I seen that, I seen this. And I know the base fine. And I know where, because it's predictable, everything in steps, so we know every step along the way, the compute and who's doing it. Let's make a new instruction that does exactly that. Does it faster and more efficiently. Because essentially it's all about the way we lay out the structure of memory. And it explores. And then it goes back into that game that I talked about. The high score concept in a video game. Where it's like bench test yourself, get a high score, there's a reward. And the reward is you get to make the modifications, right? And be satisfied. Yeah, you give it a little candy. Fusion is that. Fusion is making the new instructions that are more optimized, which means less code. But I have a cap on it, so I'm gonna probably have a codex lift that. And then also, every binary gets distributed distributor across all the machines too at the same time. At the moment, I don't. The top one, I don't have it. That's my gaming computer. I don't have it. I actually stream with. I stream to it with Moonlight remotely, but that one I don't have it for distribution. Okay. Yeah, that's cool. Okay, let me go ahead and make that change, and then we'll raise the limit and see what happens. I haven't raised the limit before because I'm concerned. I'm concerned that I can, but it's the steps. We have a limit. I don't have a limit on steps, which that's good. Let's actually go to my existing code. Are we running it from the virtual? No, from this one here. That's another problem. Virtual machines. That's another way of getting hacked. Big time. Okay, narrow kernel. Let me check this out. That's just for my Telegram, right? Okay. I don't want to do that. I'm going to strictly stick to the second code, for the first code. And it's fine. Let's start a new thread under neurobytes. Okay. Okay, let's look at my code as is. I want to increase the MB max array elements. Or, in fact, how easily would it be to, let's say, put -1 for no limits? So, it's in the main engine. That's what I do. We can just patch it. So what we're doing right now, I can't show you that stuff because I haven't released it yet. So right now what we're doing is we're patching the main engine and say, hey, -1 means unrestricted. You do whatever you want. You create as many arrays, use more memory, because we're trying to explore more complex computation. That's they're distributed. So right now I have screen sharing for that computer. Let me see. Let me close my screen share because that's just for my bot, so I don't need that in the way. Okay, so it's applying the modifications for unlimited for runtime caps. This is the best time to hack me. And I'm gonna say thank you because all Salmon, all Sam Altman, not Sam Salmon. Papi, ¿qué pasó con eso? I'm gonna say thank you always. Thank you. Please distribute it across all my machines. Thank you. It's still in the project, so I should remember. One thing I learned, because I'm actually having it deploy stuff into to those two nodes from Codex. I have the full access mode. That's kind of scary because they can literally just delete my files, format everything, and just guys can just send me back to the Stone Age. Use key. It say it wants my password. I'm not gonna give you my password, buddy. Use the key that I gave you. I give you the password, you can sudo go root, bah, take over my computer, laugh at me, burn it. I don't trust you, buddy. Wait, let's look at this. So you see my my point 39 does nothing. It's on music. I need people. I need people to come and say, hey, nice hardware, can we play around with it? We need to start with exploring again the internet. Things have gotten boring here. even look. Okay, then let's see. Paramicos is, dude. You have Paramico. What's wrong with you? It's just stalling you right now. Oh, now you're creating an environment. You already had an environment, buddy. This thing was gonna come back and kill all of us. I don't stream this because there is some sensitive information that I don't want to show anybody. It does remember. Okay. We're gonna come back to ChatGPT here, and we're gonna say, okay, give me the best you have. I lifted limits. Yo, this is so wrong. I wonder if all my cores are just gonna start going. The epic server. It's loud. It's super loud. So that's why I can only use it at nighttime. During the day, I have the fans. I think it's like 80, like almost 90 decibels. Just the fans for. Like my gaming computer. Like, let's look at the temperature here. It should be in the 20s. It should be low. I gotta figure out what's using the most. Node. What do I have installed on that computer? Oh, well, just for this, but that's and a remote PC. I gotta get rid of that remote PC. Okay, cool. Metrics are updated. Alright, so this code should technically work now. Let's refresh. And I gotta come fix all this stuff here because it's overlapping. This micro slop. Alright, it should actually distribute. And we should see it in real time. Alright, so it made a little mistake. So let it. Is this gonna do 8.6 billion? This is the prediction that it has. Is it? We'll find out, buddy. This is the Titan code. This is probably what's gonna kill my computer. Let's do it. You still messed up, buddy. You still messed up. I don't wanna. What's going on with you, buddy? If not, I'll just give it to Codex. Codex will take over and then figure out. So what you do with my Codex, the way I have it set up is, I give it the code that it generates, the ChatGPT generates, and then I give it the error. And then it will figure out, okay, so this code doesn't work because it's actually using this instruction the wrong way. Then Codex will make the change. Then I'll generate a new documentation that's up to date. Then I give that documentation to ChatGPT. I mean, if anything good comes out of this, these people are getting wealthy out of us. And I'm paying $20 plus API. This is theft. I would like people to come and let me see. Okay, it says to hammer it with this one and see what happens. So we're gonna hammer it with that one. Oop. So this is what I do. I go to my Codex, I say, ChatGPT gave me this code, but my side gives me this error. Because it understands my code better. What is it doing wrong? Any changes we have to Codex is gonna go and say, well, actually, they did a pretty good job, but Codex is not a conversational one. We know the Codex is strictly, I'm gonna look at this, let me iterate through this, hold on, this is wrong. Let me fix this, let me copy it. Okay, it's still probably gonna spike because it's gonna run the program to test it. It shouldn't run it locally on my Mac Mini because it'll kill my Mac Mini. I'm finishing up. I'm live for a second, Mama. I'm on YouTube live. Okay, so right now is checking the engine to see why. Let me see. Okay, so yeah, I forgot to make the patches on the nodes. The nodes still had a 200,000 array limit, so now it's patching it and then deploying it to the cluster, and then we'll come back and then we'll be able to send that, distribute that load. You know, I wish I had like 100 computers and then send it across all of them, and then maybe vibe code with an algorithm that optimizes it for latency. So that kind of stuff is what we're exploring this week. I got stuck in the first part of the week. I got stuck with optimization for the AVX2 instructions. Okay, did it test it? I got some spikes there. I think it did test briefly. Okay, should have recompiled it again and send it. So the main engine program on my server for my website, it's valid. I don't need it there, but I have it there so it can validate the code. Cool. It said to go ahead and just pull the trigger. Let's refresh. Right, Codex doesn't lie. Right. Let's do this one first. Okay. So then let's do this one. Let's go ahead and hammer it across. So I'm gonna say still getting same error. I promise Codex for the most part gets it on the second time. No problemo. And then also the data that we're getting here, I need to figure out how to visually probably go on a matplot or something, just plotting it. Probably have an endpoint for that too. Let's see, while we wait for Codex. Codex is the brain of the operation here. I just orchestrate. Okay. It's gonna check the cap, so we're probably gonna have a slight spike here. And then the .48 is my Epic server, and that one, you see the anomaly score changes more, so that's doing a little bit more work. That might be the camera. Okay, it's a virtual machine, but that's not even running at a 1%, so there might be something wrong with the score there. And then also bothers me that I gotta change some, like cinnamon right here. 49.5%. What are you talking about? Cinnamon. That's wasted watts. I mean, that could be a quarter of a watt right there. It said it races to 1,000,000, the cap. It's going to race it to the 1,000,000, and then we'll go from there. And I didn't ask you to do that. I basically told it to give me unlimited, so. Most of the time, so we need to make this more exciting. Okay, say to fix it. Okay, it said go ahead and give it a try. That's what it said. And we know that ChatGPT doesn't lie. Codex doesn't lie, so. Oh, it did it. Holy moly. It worked. There we go. Alright, so we're gonna give this code to ChatGPT. How many did I use? Dude, we raced to 1,000,000, but it didn't even use them. So that means let's go to the code that apparently was too big for it to run. Aha! Still got a problem with Titan. You got a problema with Titan. But it doesn't have a problem with this one here. Alright, so that took 84 milliseconds. Let's see how it disrespects our engine and starts talking bad about how inefficient it is. It took me 2 days to put it together with the help of Codex. We're gonna summarize this here. Almost done. Alright, let's wait for the results. And then I'll come back later after midnight. Maybe around 1 in the morning, you know? Gotta go workflow. Okay, there you go. Alright, so let's see what ChatGPT says about my piece of software. Good results. Your engine is doing really good. Okay, let's see. So still about 44%. Some orchestration overhead issues. It says your allocator is growing beyond exact usage. This is not bad, but it means total memory pressure is higher than the raw memory count. So it says. Yeah, I mean, I'm using OpenPP distribution. Okay. Let's go ahead and run this one too. Why not? Let's see what happens. Boom, 154. Come on. It's thinking. Maybe we could do deep research. I can get all my the research that I've done in the past couple of days, and give it to ChatGPT in a project and have it do deep research to see where I'm making improvements in the project and what I'm doing wrong. Okay, so we're using about 70.6% of the max limit of 1 million. Okay, so now what it doesn't, my Epic, I can raise it to 2.5 gigahertz frequency, but then I will blow up the battery backup at the office. So if anybody wants to send me money, I'll buy another battery backup. I need a 2000 watt battery backup. What we're gonna do is, as we finalize this, I'm gonna go back to Codex. I'm gonna run this again, and I'm gonna tell it, hey, one of the notes is faster than the other. What can we do about balancing it? Maybe make some changes here and there to better balance it. Okay, we go. So we saturated the entire memory space. Alright, so 576 is effectively the largest matrix size possible with 3 array under the current 1 million limit. So we use about 12.58 megabytes. And nodes execution time is about the same. Okay, so I changed the thread count. So it's actually compute bound. Okay, so 2 remote nodes, each performing 576 by 576 matrix multiple. Alright, so the rough compute estimate per node. 2 loops. Okay, so we're doing a total of 382 million floating points operation. So across 2 nodes, 764 million operations. That's already a serious workload for a DSL runtime. So it's saying that I can play around with between 384 and 512 matrices. Alright, we'll raise it to, so what I'm going to do when I come back later, I'm going to raise it to 5 million, right? Because if I run this a few times, that's not going to do much. You see the spikes there? My Epic barely spikes above that. Temperature looks good. And also, I'm not getting temperature from my Epic server. And also, what I have here is every time you run it, it's actually, it catches, it actually compiles it. So you see right here, like engine version 15. I don't think the neural network in the background is working because it should be compiling. That's part of what I told Codex. It needed to compile itself once it found the most efficient. But that would actually use some processing time, so I have to implement that part also. So this is neurobytes.org. There's a limit, there's a fail to ban is pretty aggressive, so if you try too much to overload it, you're gonna get banned. Come in here, I will include the documentation for the engine, so that you can write your own programs and just copy and paste them. For sure, use ChatGPT 5.2 or Codex to have it generate the programs for you, because the order does matter. In some cases, there might be a bug in the scripting and the syntax itself. So it's not perfect, but come and take a look at it. What I'm going to do is I'm not going to log anybody's IPs or anything like that. But if you start doing 5, 6 consecutively like this, if you do this, you're going to get banned. Watch what's going to happen. You're making, there you go, rate limit. And then also, you're not going to kill my computers because every time you run it, because it's already pre-compiled, what it does is I thought about this idea called expectation. And this high-level concept of expectation means if we already have an application in this engine that has been executed, we already know what the output looks like. So the output is already catch. So even though it looks like it's spiking again, the distribution is coming through, but we might have some miscatch, but it's being catch. And that's happening on the server side. Not the nodes, but it's happening on the server side. So, but I still see it come through a little bit. Okay, so if I do it again, okay, 1, 2, space it out. Do you see how I press it twice again, and then you don't have that spike again? They're like flat. I'm running it. That's called catch. Now I may be missing a few in between. Okay, that was perfect. 1, 2, and you can do it like a pattern, right? Like 1, 2, because you're using time as a way of measuring. So 1, 2, 1, 2, and you notice the milliseconds drop over time. That's catch. So because if you take, okay, it banned me again. If you take execution time over n and you have a base, and then you go from 80 milliseconds, 180 milliseconds, and then you drop to 35 or 20, then you know it's being catch. It's either it's running in catch, or it's being distributed across more nodes to decrease that number. Obviously, I'm not increasing the nodes because I'm not Elon, who has 1 billion trillion computers. But that's what's happening. All right, hold on. ChatGPT just told me that it finished doing something. Nope. It's hallucinating. But yeah, thanks for watching. Please like and subscribe. Right now this week, my main focus was optimizing loops and recursive functions, and then I got lost with matrices and AVX. Just kind of learning how to talk the language of my computers. The instruction set and how they perform. Again, an RTX, a video card, even an RTX 3060 will beat all my hardware in a blink of an eye. But that's a general purpose computing. We're trying to really work with branches, so that's what the CPU is really good at. And okay, something happened here. This is another bug in my program. Sometimes you're gonna get fetched fail, which means just refresh the page. I don't even know why it's doing that. There you go. It might be like a timeout because I had some authentication here temporarily. That's why it says open mode. I was thinking like maybe register, but I was like, I'm just gonna open it to the public. Have the public use it. Look, you have data sets. You can actually come here and store this data set, and then you can train. Sort of train. For example, look at this. XOR neural net. Load it up. That's not it. And we come. Okay. So it has a history of all the codes that we generated. Like for example, this one. That's just data set. What am I doing? Should be around here. Check this out. So we come here, data set, we load that up. it's hiding. I gotta fix this, guys. I'm sorry. It's vibe coding. There we go. It takes that CSV file, and my idea was that I can open this to the public so you can train it on small little models, and then you can export them, and then you do whatever you want locally. Yeah, I don't think. There you go. So this is from the Reload. Alright, just play around with it, please. Don't abuse it, or I'm just going to go there permanently and ban your IP. You already saw my management tool. I'm going to add networking, IP, and then if I find something, I'm just going to ban you. So, neurobytes.org, right here. I'm going to make it bigger for you. Please do not abuse my machines. Be nice with them. I'll include the README file on my GitHub, so that way you know how the language structure, and then just play around with it, and then please like and subscribe. Thanks for watching.